3.7, modeling using variation preparation. Example, Eva is paid an hourly wage. 1 week she worked 43 hours and was paid $795.50. How much does she earn per hour? Okay, we know this is a direct relationship. So we know we're going to end up with, so this is how much the total pay is. So we could, for instance, say pay is equal to your number of hours worked multiplied by your hourly wage. In this case, we know that when she made $795.50, that was the pay. It says they worked 43 hours. 43 hours. And that's multiplied by the wage. Or we could put a K there if we want to kind of more standardize. But the wage, right? So 43 hours multiplied by the wage gave us $795.50. Okay, cool. So to solve for W, we divide both sides by 43. Okay? So 43 cancels out with 43. And $795.50 divided by 43 gives me $18.50 is equal to W. How much does she earn per hour? $18.50. Hooke's law for an elastic spring states that the distance a spring stretches is directly proportional to force applied. With a force of 150 newtons stretches a certain spring 8 centimeters. How much will a force of 400 newtons stretch the spring? Okay, cool. So it did say that directly proportional, so we are dealing with a multiplication situation again. So we could say something like distance direct. We don't know what the direct thing is. I'm going to put a K there, but they did say direct, so now we're going to multiply, right? So distance is equal to directly, and then directly is what? Force applied. Force applied. So I can use F. Okay, now they gave us a situation where a force of 150 newtons, all right, so K times 150, that was the force, stretches the spring 8 centimeters. 8 centimeters. Cool. Now we want to solve for K. Divide by 150, divide by 150, cancel, cancel. We end up with K is equal to 8 over 150. Okay, cool. Now I can rewrite the original one with 8 over 150. You can rewrite that as a decimal if you want to as well. It's not really necessary, though. You can just leave it. All right, so, and that's multiplied by F, the force. Okay, now we want to say, how will a force of 400 newtons stretch the spring? Okay, so we say 8 over 150 multiplied by the force, which is 400. And that gives me distance of 21 1/3 centimeters. And that's what we end up with. You could have just as easily written that as a decimal. I don't think it's a nice decimal, though, so I just left it as a fraction in order to not deal with decimals, but that's what you would end up with. Okay, direct variation as a power y varies directly as the nth power of x. Now, variation doesn't just, it can be direct, but it can be direct to something to another power. It can be directly as the square, directly as the cube, directly as to, that's what they mean by the nth power there, is it can be directly as that variable to some other power other than 1. Okay, so let's try one. So the distance a body falls from a rest varies directly as the square of the time it falls. Okay, so we would say something like, well, distance, and then we have the unknown. Let's say the distance varies directly. That's where I got the multiplication. That's as far as I am. They said the square of the time. Okay, well, time squared. Don't confuse square with square root, right? Square root is this, right? And square is that. So this is the one we're interested in when we say square. Otherwise, we'd say square root. Okay, that's not what we're dealing with. Okay. Now, a skydiver falls 64 seconds. So the distance is, 64 feet in 2 seconds. So we say K is equal to 2 squared. Okay, so I'm going to try not to skip any steps here. 2 squared is actually equal to 4. So now we end up with 64 is equal to K times 4, or 4K. And we undo the multiplication of K by 4 by dividing by 4. Whatever we do to one side, we do to the other. So 64 divided by 4 gives me 16, so we get K is equal to 16. Cool. Now I get to rewrite my original equation of distance is equal to K multiplied by T squared, but instead of writing the K there, now that I know the K is 16, I can put 16 T squared. Okay, now they're going to give me some new information. I'm going to figure out a new distance in this case. So they said how far, which is the distance, will she fall in 8 seconds? So d is equal to 16 times 8 squared, which means d is equal to 16 times 64, which means d is equal to 1024. All right. Now they say inverse variation. Now inverse is a bit different. So when they say inverse, varies inversely, you're going to divide. So for instance, I say y is equal to k. They all start that way though, the variation problems. Y is equal to k. If they said direct at this point, I would be multiplying. If they say direct to some power, square, cube, whatever, I would bring that, whatever that variable is, to that power. Not the k, but whatever the next thing comes. But when they say inversely, I'm going to divide. Now they can do the same thing with inversely power, right? They can say it varies inversely with the square, inversely with the cube, inversely with the nth power as well. Okay, but the main thing right now we want to focus on is when they say inverse, we are dividing by that variable. Okay, so let's try a few that aren't standardized as y is equal to k over x. So what about h varies inversely, right? So inversely. Now once they say varies, we're already up to this point. H equals k. H varies. So h equals k. When they say inversely, divide, and they say as w, put the w down here. All right, let's try the next one. P, right? P equals varies k inversely. That's where I got that, right? Inversely. And they said as d. See how I tore it apart? So we say p varies, so p is equal to k. Inversely divide as d, divide by d. Okay, now we have d is inversely proportional to t. So we have k, d is equal to k, inversely proportional to t. And we put the t on the bottom right there. Hopefully that makes sense.